To Unit 6, Lesson 12, where we will continue with equations, but also start to discuss some percentage increases and percentage decreases. So in our last couple of videos, we've talked a lot about solving equations and being able to find that solution, which is usually going to be seen as the variable x. But now we really want to dive into working with negatives and percents. Before we go any further, let's really break down the word percent. Now, percent, right? You see that word, what does it mean? I have per, which is the first part of the word, and then cent, which signifies 100. So I'm talking about out of 100. Every percent that I have is going to be out of 100. So if I have 65%, that will in turn will be the fraction 65 out of 100. So in order to dive a little more into this, we are going to be talking about sales and shopping, two of my favorite things. So we're going to talk about one of our friends, Diego, who goes to a store that's having a sale on all shoes that are discounted by 20%. So Diego also has a coupon that takes $3 off the regular price for one pair of shoes. So the store will first apply the coupon and then take 20% off the reduced price. Make sense? So, just to break it down, the store is having a sale, 20% off all shoes. Amazing. 2, Diego has a coupon for $3 off. Once he goes to the store, the cashier first takes the coupon and then it takes 20% off the price of the shoes. So if Diego pays $18.40 for a pair of shoes, what was the original price? Let's see if we can try to do this together. So here's what we know. 1, all the shoes are discounted 20%. 2, the coupon is for $3 off. 3, the store first applies the coupon, then 20% off the reduced price. And 4, Diego's total price after everything was $18.40. What could the original price be? Pause the video and try this on your own. First, I'm going to try to make an equation. Now, I know that the total price after all of the reductions was $18.40. So that's what I'm going to set my equation equal to. All right, step 1 done. Now I'm going to take a look at my data again. Well, I know that I'm looking and solving for some value, so I'm going to give that value the original price, the variable x. Now that I know that, I'm going to ask myself, okay, what's the first thing that they did to x? Well, in step 3, it tells me that they first applied the coupon. So whatever the price was originally, they first took $3 off. So x minus 3. Then it says that they took 20% off the reduced price. All right, let's think about it. If they took 20% off, then what percentage of the shoes did Diego really pay for? One more time. If they took 20% off of the shoes, what percent of the shoe did Diego pay for? Yeah, he ended up paying for 80% of the shoes because 20% was taken off. Now, what's an easier way that I can multiply percents? Yeah, awesome, by converting it to a decimal. So 8/10 is equivalent to 80%. For now, the rest of my equation remains the same. From here, pause the video and try to solve for the variable on your own. So one of the first things that I can do is I could distribute or divide. Here, I started by dividing. I divided both sides of my equation by 8/10. As you can see, my 8/10 crosses out on this side, and on the other side, once I solve, I have x minus 3 is equal to 23. And remember, because we are at home, feel more than welcome to use your calculator, so plug in 18 and 4/10 divided by 8/10. Awesome. From here, what possible value minus 3 is going to give me 23. If you can't think about it at the top of your head, that's okay. Let's go ahead and add 3 to both sides. X is equal to 26. So the original price of the shoes was $26, and after the coupon, after the discount, Diego only paid $18. Shout out to you, Diego, that's a bargain. Now something else in the store is going on. Before the sale, the store had 100 pairs of flip-flops in stock, right? Right in the back, they had 100 pairs. After selling them, they noticed that 3/5 of the flip-flops they have left are blue. If the store has 39 pairs of blue flip-flops, how many pairs of flip-flops have they sold? So here are the key pieces of information that we know. There are 100 flip-flops to start. 3/5 left are blue flip-flops. And then 39 total pairs are left. We want to know how many total flip-flops have been sold. Again, we're going to start with our equation. I'm going to set it equal to 39 because that's how many flip-flops they have left. I'm looking for the variable x. In this case, x is going to mean how many total flip-flops we have sold. So 100 minus x is equal to 39. However, I'm not done with my equation because 39 is only the number of blue pairs left. So I have to start with that fraction in front of my parentheses because that's the fraction that are left, which are blue. From here, try to solve the equation on your own. Now, to cancel out this fraction, what I can do is multiply by its reciprocal. When I'm multiplying by a whole number, I can just put it over 1, which will convert it to a fraction. From here, is there anything that we can reduce right off the bat? Well, 3 is divisible by 3, and it's going to equal 1. 39 is also divisible by 3. What's 39 divided by 3? Awesome, 13. Now I can just multiply across normally. 5 times 13 equals 65. 100 minus what number is going to equal 65? Awesome, 100 minus 35. So x is going to equal 35. So even though that was tricky, to bring it back in terms of the problem, after all the flip-flops had been sold when they went to check, 35 pairs of flip-flops were the ones that they had sold. So in all, I know some of this can be really